Hello everyone, I'm Cuong from Monash University. Today I would like to present my work Frequency Attention for Knowledge Distillation. This is joint work with Van-Anh, Nguyen, Trung, Phung, Gustavo and Thanh-Toan. So let's jump into my work. Knowledge distillation is an objective approach for learning compact deep neural network, which learns a lightweight student model by distilling knowledge from a complex teacher model. An intermediate feature-based distillation is a preferred approach due to its flexibility for designing distillation mechanism. Within these approaches, attention-based knowledge distillation employs the attention mechanism to effectively guide the student model. And as illustrated in the figure, attention is applied in the spatial domain to derive attention maps, and the maps guide the student model to focus on key information from the teacher model. However, each value of the attention map is calculated from the local region of the input feature map. The local regions might not be enough for effectively knowledge transfer when we need to capture the broader context or global information. And in frequency domain, since each frequency is determined from all pixels of the image in spatial domain, it can contain global information about the image. And to effectively knowledge transfer, capturing the broader context or global information is necessary. So, in this work, we propose leveraging the benefits of the Fourier frequency domain for effectively transferring knowledge from teacher model to student model. We propose a frequency attention module to encourage student model to better mimic teacher model. This module includes global branch and local branch. Local branch leverage the information of features in spatial domain, and global branch which has a learnable global filter in the frequency domain. The global filter can be seen as a form of attention in the frequency domain, which can adjust the frequency of student feature maps. Specifically, we first transform feature from the spatial domain to frequency domain using fast Fourier transform, and then putting it to the learnable global filter and pass it to the high pass filter to suppress low frequency. We then invert the feature in frequency domain back to the spatial domain using inverse fast Fourier transform. And finally, we use two learnable parameters, gamma 1 and gamma 2, to control the contribution of each branch to final output features. And by updating the parameter of the learnable filter based on the guidance of teacher, we can encourage the transformed student feature to have a similar patterns as the teacher features. We then present our design to integrate the FAM module into layer-to-layer feature-based distillation and knowledge review-based distillation. And for layer-to-layer KD, in order to make FAM to better mimic teacher, we find that it would be beneficial to also enhance local structure in spatial domain. Therefore, we place an attention layer after student features before feeding it through the FAM module. And in local self-attention, the self-attention is applied only to a small neighborhood around each position. And we use L2 distance as the distance function, and there is no transformation applied on teacher feature maps. And for review by KD, combining different levels of student features before receiving knowledge from teacher is an effective approach for KD. And we propose using cross attention, in which the low-level feature maps is considered as the value and key, and the high feature maps is considered as a query. When we combine student feature maps at different levels. We present top 1 classification accuracy on the Cipher 100 by various teacher-student pairs, both from the same network family and different network architectures. Overall, our methods FAM-KD consistently outperform all compared methods in all settings, and in some cases, student performance even surpasses the teacher. We also validate our approach on large-scale datasets ImageNet in the case of integrating the FAM module into the knowledge review-based distillation mechanism. In this setting, we also achieve the highest performance on both top 1 and top 5 accuracy. And as illustrated in the figure, our approach helps students to focus more on object reason. In conclusion, we propose a novel module in which we explore Fourier frequency domain for KD. The module consists of a learnable global filter that can adjust frequency of the student features. And we propose an enhanced layer-to-layer knowledge distribution model and an enhanced knowledge review-based knowledge distribution model by leveraging the proposed SAM module. We validate our approach on Sci-Fi 100 and ImageNet datasets, which outperform other knowledge distribution methods. And thanks for your attention.